let us introduce ourselves and explain why we decided to present this lecture. My name is Alisa Kuzmina. I'm an MSc student of positive psychology, and I have a bachelor degree in psychology in High School of Economics. And also, I'm a junior researcher in the Laboratory of Linguistic Conflict Resolution Studies and Contemporary Communicative Practices. And in my studies, I'm trying to integrate psychology, linguistics, and computer science. And my helper with the last thing, computer science, is Masha Lifshitz.
Hey everyone, I'm Masha. I have a bachelor degree in computer science and neuroscience. I actually started at Higher School of Economics in the psychology department, and after doing one semester here, I moved to the United States. And right now I work as a software engineer at ActionIQ. It's a data-driven startup at New York City. And in my free time, I help Alisa with her research, and my interests are in the area of machine learning and psychology.
And right now, we work together on a project that is called Manifestations of Personality Development in Textual Data. And this project was supported by the Faculty of Social Sciences of High School of Economics. And for additional information about our project, please visit our website. This presentation will be sent to you by email. So all the links will be for you. So let's start. Our topic is personality psychology and computer science for text analysis, why and how. And we have two main parts here. The first is personality psychology and why does it need text analysis methods. And the second part is computer science and how text analysis methods can be implemented in, for example, psychological research. And our view today is based on the thought that it is not obvious for psychologists how to do programming. And the first part, about personality psychology and why, will be presented by me, and the second part will be presented by Masha. So here's a plan for my part of the speech. So why does personality psychology need text analysis methods? Well, at first, I'll cover examples of texts. Then I'll give illustrations of using these texts in psychological research. And after that, I'll emphasize some troubles that are connected with implementing text analysis in psychological research. And finally, I'll summarize the key reasons for using these methods and why it's worth the effort. So, textual data in psychology. Well, by text, I mean textual data that can be presented in different ways. And I think that the most historically familiar with psychology are the following one. Interview scripts, essays that we ask our participants to write or share with us, answers on projective methods, for example, sentence completion tests, psychological articles and books, scientific publication, and maybe less familiar, but still very useful, social networks, personal blogs, dictionaries, corpora, for example, Russian National Corpus, and maybe it's important here to describe what does it mean, corpora. So corpus is a big data set of different textual data. For example, Russian National Corpus consists from different books in Russian language. And I think they are from maybe 19th century to nowadays, maybe even earlier. So yeah, it's a really cool thing to search for something. And newspapers, and of course, many others textual data sources. And as you can see, we have a lot of textual data in psychology, and the main problem is the impossibility of manual analysis of it. So let's jump into illustrations of how texts can be used in psychological research. And first is social media posts. Well, posts in social media are really popular in modern psychological research, and most of such studies are aimed to create a prediction model. For example, now it is possible to predict on Facebook, personal blogs, Twitter, and so on, Big Five and doctorate traits, alcohol drinking, suicidal behavior, character strength, well-being, and many others. And moreover, not only predictions, but also, for example, how Twitter has been used in academic conferences. So we can see that social media is a really good source for psychologists, and it can be not only like a source of data, but also an object for your study by itself. And I think that it is more about cyber psychology. It is important to mention here some questions connected with using social media in your research. And the first is sampling biases. Sites, I mean social networks, do not represent all types of people equally, and it is possible to ignore less privileged socioeconomic groups of people. And the second question is about a choice of social media. Many studies include one particular social media, for example, Facebook or Twitter, or even Vkontakte. But in real life, we use several of them, and connections between several social media sites may improve research results. And the main advantage of using social media is an opportunity to collect really big data and include in the analysis not only texts, but images, amount of friends, likes, and so on. So let's look at another source of data. And another one broad field is using computational text analysis in the meta-analysis of lots of publications. Asmussen and Moller recommends to use topic modeling method, and don't be afraid if you don't know what does it mean topic modeling, because it's okay, it's just a method. So they recommend use topic modeling for smart literature review and provide a step-by-step guide how to do it. And an example of such smart literature review is a study of approximately 6,000 articles on mindfulness. And this research makes possible analyzing the whole field that is grown exponentially and cannot be catched by an eye. And also there is a study that investigates evolution of the delirium literature over time. It consists from 3,500 articles within a period of 20 years. So computational analysis of literature allows to highlight trends in whole field analyze the development of different concepts in a field, and moreover, investigate methodological problems and opportunities in the field. And one more type of text that I'll shortly cover is dictionaries. And I think that if you're a psychologist, you already know who you will see on the next slide. Because, yeah, it's Allport. So in 1936, as I remember, American psychologist Gordon Allport, that you can see on the slide, and Oddbird began to focus on finding the most efficacious way to describe differences between people's personalities. And they suggested that the individual differences that are most salient and socially relevant in people's lives become encoded into their language. And this hypothesis is called lexical hypothesis. In short, their research of dictionaries, and they made a list of 4,500 adjectives that describe personality. This research made possible for Big Five model to be created. And the Big Five are now accepted by most personality researchers and is really influential. And I'm talking about it here because it is an example of how text analysis can be used for theoretical work. And of course, nowadays it's much easier to analyze dictionaries because you don't have to do it manually. So let's sum up and cover main problems that you may face. And I think that they are not surprising. I'm sure that you know about this kind of problems from other methods. So the first is data selection. And by that, I mean both what source to choose, social media or dictionaries or interview scripts. I think it based on your research field and of course, data that you already have. And also by data selection, I mean a problem that I have already mentioned before, that sometimes your source cannot represent all groups of people. And this is the thing that you should keep in mind. The next main problem is content validity. And there are too many studies focused on prediction only. So it's important to remember about understanding of the results and understanding of theory that is under your numbers and under your texts. And the last thing is programming skills. Of course, to use method, you have to know how it works and how to do it. And a little spoiler, it's not so boring and hard as you may think. And here is my last point for today. So why does personality psychology need text analysis methods? Or why it worth the effort? So the short answer is language. We use it in psychological research from the very beginning. When Wilhelm Wundt asked his participants to introspect something, he used language. He analyzed their answers in language. When we create a questionnaire, we use language. And understanding of linguistics and modern methods of computational linguistics allows us to be more effective researchers. I think that it's like one day it became able to get rid of manual calculations of correlations. Just like that, today we have additional tools for enormous amount of text that we cannot read by ourselves. It's not an obligation, at least for now, but it is a wonderful chance for opportunities. Thank you so much for listening. I think it's high time to start our second part. Masha, I think now it's your turn. Are you ready? And maybe we need some time to switch our presentations.
Cool. Yeah, I'm ready. I'm going to stop your sharing and share my screen.
Yeah, thank you.
And I'm going to switch it to the actual slide that I need. So the problem that actually is happening right now is that after you got your degree in psychology, linguistics, or computer science, you realize that it's not actually enough because you might have just one of the things you have on the picture. You have either basic technical skills, or you know linguistics, or you know something. But putting it all together, making sense of it, is really hard. Computer scientists often lack the domain knowledge. They don't know what psychology is, how it works. They don't know theories. They don't know what's important. And psychologists often know what's important, but they have no clue how to do text analysis and programming with their knowledge. And it's really hard to catch up and figure out how to get all the skills for yourself. And that's why collaboration is important. And one of the main problems with collaboration is the communication, because you don't want to have a blind leading a blind. You want to give your partner enough explanation so they know what they're doing. And it's hard because there isn't an actual language that you can communicate with, because you know some words, your partner knows some words, and they don't align. So I hope that this lecture will give you at least basic vocabulary to use and maybe some starting point to move on and start your research with computer science involved. So we all hear words like CS, AI, ML, NLP, and the main question that appears in our head is like, what? What does it actually mean? Is AI like artificial intelligence that will conquer the world and we should be worried about it? Well, according to Elon Musk, the answer is yes. I wouldn't be so sure, because AI is actually a very complicated field that includes many, many different things. And in our lecture, I'm going to be focusing mainly on machine learning and NLP. And though both of those words, NLP stands for natural language processing, can be very confusing and hard, I'm going to try and make them a little bit more clear. Let's start with a quick history of natural language processing and computational linguistics. So as many of you know, there was Alan Turing, who said that he believes that computers can imitate humans at a reasonable level. And at the same time, John Searle introduced the Chinese room experiment, where he said that if one is given a collection of rules, the computer can emulate natural language understanding just by applying those rules to the data. Like, let's take the John Searle and assume that he's a computer in this case. If we put him in a room and we give him a dictionary, he doesn't know Chinese, but if he has very specific instructions on how to translate Chinese symbols, he can do that very easily without really understanding anything. And that experiment kind of led the researchers to the conclusion that in 5 years, they will be able to do human-level translations with machines. Needless to say, that didn't really work. And here we are now in 2020, still figuring out how to make computers understand humans. And the problem is that there isn't a specific set of rules that we can teach a computer, but there is some stuff that we can teach it. And before I begin talking about machine learning in detail, I just want to give a brief overview. There are a lot of words in the field that often overlap, and I thought that it would be important to separate them and explain maybe a little bit of a difference between them. So there are methods of computational linguistics, and those are the research methods that you use. Technically, you can assume that you're not using computers for that as well. There's sentiment analysis, where you determine the sentiment of a text. There's topic modeling, mentioned by Alyssa previously, where you figure out what the topic of a text is, or several topics. There is text classification, which is important for different research methodologies, such as projective methods. They're models. Models are actually algorithms that you use to complete the tasks above. You can use neural networks, linear regression, random forest, and so many others. And you can read about all of them, and they're just models that you apply to whatever data you have. There are techniques that are specific to the text data that allow you to pre-process the data in a way that helps the computer to understand it and helps you to work with it in the future, such as stemming, synonyms, stop words, TF-IDF, and we'll talk a little bit about them later. And then lastly, there are tools and libraries such as GenSim, PyMorphe, Scikit-learn, Word2Vec, and others. And again, we'll cover some of them in the next slides. So machine learning, we don't really know what it is when we hear it the first time. We know that it has something to do with computer vision and translation and computers being smart and all that stuff. But actually, machine learning is primarily the search for patterns. You can't explain a concept to a computer, but you can show a pattern and the computer will see that pattern, understand it, and use it in the future. Like, let's say books. I know the picture is about humans and we'll talk about it later, but let's start with books. You have a book and you know that the more pages a book has, the thicker it is. So based on that data, and the more data you give to the computer, the more accurate the prediction is. The computer learns to see the pattern, the correlation, and make accurate predictions. Same can happen with the humans. See, based on the body weight, you can predict the height and vice versa. So the way it generally works, you have your data, which contains some patterns. You have a model. Remember, we talked about them. It's basically the engine of our research. It can be whatever, and based on which model you choose, there are different little things. But at this point, it doesn't really matter which one you chose, something that finds a pattern. So model finds a pattern. And originally it assumes that there is actually no pattern at all, that the data you're looking at is meaningless. And it compares its own prediction that the data is meaningless to the actual answers and adapts. And this loop goes multiple times, and depending on a model, it can go like 1,000 iterations or more. It adjusts, and then when you have a trained model and you train it on the trained data, you take the new data, the data that computer hasn't seen before, and using the model, you make the prediction. And if you trained your model well enough and you were smart about it, you get accurate predictions for all the new data. But what if you want to add more factors, right? If a book has many pages and it's thick, that's great, but what if it's still thick just because it...
Masha, I'm sorry. Yeah.
Yeah, you kind of muted me. That's fine.
Thank you.
Yeah. So you have more factors. You can just add them as parameters. And we're going to talk about this specific case to see how that works with words, because words for computer are just parameters. This is like one of the simplest examples there is. So I hope that it makes sense. And I'm going to open the chat and take a look at it once in a while if you have questions as I go. So we have a set of data. In this case, there are 2 sentences that are going to be our training data. I like my cat, I hate your cat. And a test data, which is I hate your dog. First of all, we'll look at the vocabulary of our data. And we say there are all those words, I like my, your, cat, dog, hate. Then we realize that computer can't actually read and the words don't mean anything to it. So we need to encode it in a way that it would understand. The simplest way of doing it is just saying if a word is present or not, and that's what we're going to do here. We see that the word I is present in both, so 1, 1. The word like, the second word, is only present in the first one, so 1 here, 0 here. We do the same with all the words in the sentence and in vocabulary. At the end, we have one hot encoding vectors, and we match them to the answers. In this case, we assume that 0 is a positive emotion and 1 is a negative one. So we have representation of the first phrase as a vector, and we have a value assigned to it, 0, a positive emotion. We have a vector representation of a second sentence and a value assigned to it, 1, negative emotion. That's our input for the training. We also do the same encoding for the testing, but for the testing, we won't give the machine the answer right away. We'll first ask it for the prediction and then compare it to the actual answer. I'm going to simplify what's going to happen here a little bit, just with words instead of actual algorithmic equations, but I think it will make sense. So what computer does, it looks at the data it has, and it tries to figure out meaningful features, meaningful parameters. So it's going to look at both sentences and see that both of them, even though their values are different, have the first word. So the first word in this case is meaningless. However, the second word is only happening in the second sentence, in the first sentence. So the second word is meaningful and the third one as well. The fourth one, however, is only seen in the second sentence. Same with the word number 7. Basically, looking at that, computer realizes that when it sees the word number 2 and number 3, the meaning is positive. It should be 0. However, when it sees the word number 4 and number 7, the meaning is positive and should be 1. Now, looking at the test example that we're giving to the computer, we can take a look and imagine that we're a computer ourselves. So we see that there is a word number 4. That's 1 point for the negative. There isn't the word number 2 and number 3, so nothing for the positive. We see that there is a word that we haven't previously met, the word dog. Computer doesn't know it, but we do. But it doesn't mean anything. We haven't met it. There are no prediction based on it. And lastly, we see the word number 7, strongly associated with the negative sentiment. So 2 words for negative, nothing for positive, and some neutral words. The computer makes prediction that the sentence is negative. And it's true, the sentence is indeed negative. And that's sentiment analysis, very basic case of very simple sentiment analysis. The computer just determined the emotion of your text. Cool, but what if you want to say something more than just plus or minus? What if you want to say if it's funny, or if it's sad, or if it's scary? It seems like it's kind of hard to explain to a computer how to do that. And it's true, computer only understands binary, or like only really understands binary. So instead of asking it which emotion it is, you can ask binary questions. Is it fear? And the computer will answer yes or no with a certain level of certainty. Like if it has 2 negative words and 1 positive, it'd be like, 60% sure it's negative. And then you compare the results and see which emotion is stronger in this text. Is it fear? Yes. Is it love? No. Is it funny? No. Is it sad? Yes. And let's say that you have sadness and fear, and sadness has a much higher percentage of confidence than fear. So the computer will go with sadness, and you can actually classify into multiple groups this way. But that seems like that's just numbers. Like it doesn't have any meaning. We're just looking at if something is occurring or not. How does it make sense? That's true. That's pretty much statistical approach, and it's called bag of words because it doesn't actually account for the word sequence or for the word meaning. But there are other methods that actually help you deal with that. And the first one, the most famous one, that is actually how Google search works, is TF-IDF. TF stands for term frequency, and IDF stands for inverse document frequency. Basically, instead of just saying 1 or 0, we're actually assigning a weight to the incidence of the word. So if we see a word, we say how meaningful it is for us to see it. Like if we see the word I, it's not meaningful because we see it in all the documents. Or maybe it's a collection where everyone is supposed to be talking in the third person, and then the word I is only met rarely, and then it's very meaningful. So based on the TF-IDF, we see how often the term is met in a specific document. And when I say document, it actually can be a sentence or a tweet or a Facebook post versus how often it's met in the collection at all. That way we weight the term, and that allows us to make more specific predictions. But that's not all we can do. There are also embeddings, and one of the most famous embeddings is Word2Vec. Word2Vec looks at the words and trains itself to see the relation between the words. It doesn't really understand what the words mean. King or queen, man or woman, it doesn't know what it is, but it knows that the relationship between queen and woman is the same as between king and man. And actually, talking about math, if you take the value, the vector value of the queen, you can see that it's actually king minus man plus woman. So the computer, even though it doesn't understand what the words mean and only has a mathematical representation of them, can actually make guesses about the words that are close to them. That is just one example of embeddings. What embedding is in general is a way of word representation other than just one hot encoding. And then it can be used multiple different ways. For example, on this picture, the embedding is used to visualize the genre of the literature, right? You can see that Encyclopedia Britannica is nonfiction, Jane Eyre is a novel, 1984 is a novel as well, etc. There are multiple embeddings that are used in the modern computer science. However, if I start talking about them, we'll find ourselves 3 hours later knowing everything about them maybe, but I'm not gonna do that. Okay, so there are embeddings, but that sounds really complicated. How do you train one? Does it mean that you have to have all the words in all the forms, like run, running, runner? The answer is that actually no, you don't have to, because there are methods of pre-processing your text and making sure that your words have, you don't need all the words in the world to train your model to have accurate output. Because you can use stemming, and when I say stemming, I mean that you can have a word running and then stem it and you have a word run. And you do the same with the word runner or like running, and then you have the same root. And the machine recognizes the word, anything that contains the word run, as a similar meaning. You can use synonyms. So instead of including all the words like girl, young lady, girlfriend together, you can use a dictionary and say that if you see the word girl and you computed its meaning, then you can say that the word young lady or anything else has the same approximate meaning as the word girl. Then you have stop words. Stop words are the words that you don't actually need for your analysis because they're meaningless. And this is really important because often people just take the list of stop words from the internet, and they usually include all the pronouns and all the common connectors like and, but, etc. And the important thing to understand is that if your research actually requires you to look at the pronouns, you don't want to exclude them. You want to make sure that you're looking at your stop words and making sure that your stop words make sense to you, that they're actually garbage. They're not something that is very important for your research and you're taking them out. Okay, so we can stem, we can find synonyms, we can do stop words, we can do so many other things, but what if you actually want to look at the word form? Like you don't want to lose it, you don't want to just have an infinitive. And the answer is one of the greatest things about computer science is that you can have multidimensional data. So you can include word and form and include them as pieces of data and look at both of them when you're doing research. And if the form is meaningless, then it won't affect it. But if it is meaningful, then it will treat it as different things. Okay, so that was a lot of information. Great. Doesn't mean that I actually have to know all the coding stuff to do all of it. And their answer is complicated because on one hand, yes, if you want to do complex models and figure out complex data, it would be really helpful to know this. Otherwise, you're just working with a black box. You're putting some data in, you're getting some results out. You have no clue what's happening in between. But if you just want to see how it works and do some basic stuff, then no, you don't have to know the coding stuff because there are things that do it for you. And I'm gonna try and show you. Oh, I can actually do it. I wasn't sure if the presentation will allow me. This is an example of one of the word clouds that Alyssa and I worked on. As you can see, it looks at the documents and it figures out what are the most important words in the specific document. In this case, we didn't do any stemming just because we wanted to actually see the idea, but you can see that the word responsibility, the word heart are the prevalent ones here. So this is Voyant Tools. They look at the data you provide and use TF-IDF to weight the data. So they make sure that this is not just incidents that like every sentence is using the word responsibility, but also that it accounts for the prevalence of this word across the documents. So pretty much this is the most important words and not just based on the occurrence. It also can find the correlations between the words if you click on a specific word, and it shows the bigrams, so the combination of the words that are often occur here. We're going to send you the presentation and you can try it out yourself and play with it. But for now, I'm just going to say that this is an awesome tool that requires basically zero computer science knowledge and provides really cool results. We actually saw a paper that was written. They pretended that it's computer science paper, but they just wrote it, including the word clouds from here. It was pretty cool. Another thing that is a little bit more computer science heavy is Google Cloud Natural Language API. That allows you to do some really cool analysis. And if you wanted me to type some specific sentence, I can, but this is the one that Google provides and we can analyze it. And yes, I'm not a robot. I assume these are the traffic lights. Perfect. So it will show you the entities and what type of entity it is. So Google is organization, Android is a consumer good. It will try to analyze and get sentiment, neutral, positive, and then how neutral and how positive it is. It will provide you with the syntaxes of the sentences and the dependencies between the words. And lastly, it will tell you what the categories are of the document that you provided. So just to see if this kind of analysis will be right for you, you can try Google Cloud Platform and then do a deep dive in computer science. Lastly, I know that this was a lot and maybe some of it made sense, but probably if you realize that this sounds something like you want to do, The next step for you would be going to Deep Learning AI. This is also a course on Coursera. They have several courses. One of them is data analysis specific. Others are just machine learning specific, and their lectures are very clear. And some of them are very beginner friendly. And they allow you to build a solid foundation in machine learning and start your research from there. Okay, so this was a lot of information. And after showing you this lecture, I'm realizing that it's not even the half of what could be said about NLP and machine learning and how it can be used. So please reach us, me at mashalivsh at gmail.com and Alyssa at kuzmina.alice@gmail.com. And we'll be happy to sit down with you, help you figure out what you're doing next in your research, and connect you with research you need.